Hi, welcome back. In the last video, we looked at some congruence postulates and ways we could show triangles are congruent without having to show all three angles are congruent and all three sides are congruent. So we had a side-side-side shortcut, a side-angle-side shortcut, an angle-side-angle shortcut, and an angle-angle-side shortcut. And then I told you that in this video, we'd be looking at what this HL stands for. Before we look at HL, I want to look at what doesn't work, because we can see all three sides work, two sides and the angle between them works, two angles and the side between them work, two angles and the side not between them work. But there's a couple things that I don't have here listed, other combinations of three letters, okay? So like I have all the sides, but I don't have angle, 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 okay? Look at my example here for what does not work. The first one here I have is angle, angle, angle. So my three angles in the triangle don't match because I can have every triangle is going to add up to 180 degrees. So here's an example where you can see I have an 80 degree, a 70 degree, and a 30 degree. Here I have an 80 degree, a 70 degree, and a 30 degree. Okay, and notice this triangle is much smaller than this triangle. So the side lengths are not going to match on this. So angle, angle, angle is never going to work with us. So anytime you are highlighting and you see all the angles, we need to remember that that is not going to work. Think AAA batteries don't prove triangles are congruent, right? Or roadside assistance does not prove triangles are congruent, okay? A good way to see an example of this is if I were to take a couple of squares, okay? Think about a square. If I take a little square, all the corners are 90, all my sides are the same, right? And if I were to divide that triangle in half, so I'd have 90 here, that's going to make 45 and 45, right? So that I have 180 degrees, and right, if that was 90, then when I divide it in half, okay? Look how little this triangle is. Right? It's little bitty. If I were going to measure that, that'd probably be about a centimeter. That would be about a centimeter. And that would be a little longer than a centimeter. Okay? But I could take another triangle that's a much bigger triangle. It's still going to, or sorry, not triangle, but square. It's still, if I draw it correctly, going to have 90-degree angles, and my sides will still be the same. And when I draw on my diagonal, it's still going to divide this into 45 and 45. So I'll still have 45 degrees, and 90 degrees, just like I have 45 degrees, and 90 degrees. But hopefully you can see that this triangle down here is much larger than this triangle here. Okay? So these would not be congruent even though all their angles would match, right? If I was going to do my circle and highlighting method, I'd say, well, I have a 45 that matches a 45, I have a 45 that matches a 45, and I have a 90 that matches a 90. Well, the three circles does not work, okay? Because the triangles could still be different sizes, even though they have all the same angles, okay? All right, another one that doesn't work is going to be angle side side, which is convenient because we don't even really want to write down that acronym if you kind of look at it, right? So if I see I have a 9 centimeter that matches a 9 centimeter and a 6 centimeter that matches a 6 centimeter, and then I have a 40-degree angle that matches a 40-degree angle. So remember, when we had two sides and the included angle, there we go, two sides and the angle in between them where the two sides came together, that worked. But here where I have two sides and the angle is not where they come together, it's not this one over here, it's over here, then it's not going to work. Because if you look, I do have here these two angles. I have 9 and 9, 6 and 6, but these angles are not going to be the same size, right? This one comes up way higher, but this has rotated where I got another 6 centimeters that I could fit down in here. So that even though it's 9 and 6, 9 and 6, and this angle hasn't changed, it's not going to be congruent triangles, Okay, and if you would like to see a real life example of that, ask during sync time or come to tutoring, because there's some neat applications on the web where you can see that in action, like a dynamic image of it. Okay, all right, so when we look and we have two sides and an angle that is not where they come together. If it's this one, we're good, because then we're side, angle, side. But if it's not, if it's one over here, then we have angle, side, side. And when we look at that acronym, we don't even want to look at that acronym. No, none of that in geometry, right? None of that in geometry. I had a student one year who said, never trust the booty. If you get the acronym booty, don't trust it, okay? Whether it's forwards or backwards. If you write it the other way around, SSA, that still doesn't work. So don't trust that booty going forwards. Don't trust that booty going backwards. However, there is an exception to it. Okay? There's an exception to angle side side. My exception to angle side side is called the hypotenuse leg postulate. Okay? When you have a right triangle, so only in right triangles. Only in right triangles does this work, okay? If you have an angle and it's 90, and then you have your two sides, I should have done that in orange, 3 matches with 3, 5 matches with 5, okay? And then my angle here is a right angle. So it's not where my two sides come together, so it's not side, angle, side. Okay? This, if I were to write it down, it would be angle, side, side. However, we can't use that one, right? Never trust the booty. In a right triangle, though, if I were to do Pythagorean theorem on this triangle, I would do a squared plus 3 squared equals 5 squared. And then if I came over here and did a squared plus 3 squared equals 5 squared, I would get the same answer for the side, and then I could prove this by side, 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 because these two would have the same side length. But the Pythagorean theorem only works on right triangles, which is why this only works in right triangles. I don't have to find the third side to use side, side, side. I can immediately call it hypotenuse leg. Okay, so in this one, I can say that triangle WUV, make sure when you do W, when you do a U and you do a V, you're very careful that you can tell the difference between your U's and your V's. Some of you, I can't tell the difference. And then triangle, if I started at W, the 90-degree angle, I have to start at X. And then I went from W to U, so from X I'm going to go across the 3 to Z, and then up to the Y. And these are congruent by the hypotenuse leg theorem, not the angle side side theorem. We never use angle side side. We never use side side angle. So this would be by hypotenuse leg. Now, it's real tempting anytime you see a right angle in a pair of triangles to go, oh, it's hypotenuse leg because it's a right triangle. But remember, you still have to check, is it angle side side in the hypotenuse leg? Do I have a hypotenuse that's congruent, 5 and 5? Do I have a leg that's congruent, 3 and 3? Okay, that's when it's hypotenuse leg, because I have a hypotenuse congruent to a hypotenuse and a leg congruent to a leg. Okay? All right, let's look at a couple of examples. Can the triangles be congruent? Which postulates did you use? So when I look at this first one, I'm going to see that I have a tick mark matching a tick mark. And then I have an angle matching an angle, and V matches Y. So I do have two angles and a side. When I look back here at my little cheat sheet and I look at my highlightings, I can see I have a segment and both ends are circled. So a segment and both ends are circled. This is a yes by ASA. Okay? So can the triangles be proven congruent? I can say yes by angle, side, angle, congruence. Okay? The next one, when I look at this one, I have an angle for sure because I have a 90-degree angle and it's going to be 90 on both sides. Okay, and then it kind of looks like that's all we have. But since this top triangle and the bottom triangle share this piece here, we can say that's congruent, and that is using what's called the reflexive property of equality. These are congruent by the reflexive property of equality. That says that YA in the top triangle is congruent to YA in the bottom triangle. YA is congruent to YA, which is perfectly fine. That's called the reflexive property of equality when you say segment YA is congruent to segment YA. Okay? So when I look at this, I don't know anything else. I can't assume that these two are equal, even though they look equal. I can't assume that these two are equal. Okay? So I can only go with what's marked in my picture unless it's something like a reflexive property or other things that we have learned have to always be congruent. So when I look at this, all I have is a segment with one circle. So when I look, the only place I have just one circle, I have two segments, right? And everywhere where I have one segment, I have two circles. So this, I don't have enough information. So when it says, can the triangles be proven congruent? This one I have to say no, because I do not have enough information. Okay? I think they must be mowing the lawn outside. Okay. All right, let's look at this last one. On this last one, I can see my top triangle has a tick mark on it that matches with the bottom triangle. I can see I have angle D matches with angle G, and that's all I see in my picture. However, I remember that vertical angles are congruent. So this angle right here is going to be congruent to this angle right here because they are vertical, and vertical angles are always congruent. Okay, they're never going to mark that in the picture for me. At this point, I just need to be able to remember that when I see it. So I do have another angle there. Okay, so I have two angles and a side. When I compare that to my little cheat sheet here, where I've got two angles on both of these, I need to decide which one is this. Is my side connecting my two angles, or is it not connecting my two angles? Look at my side. It's not connecting my two angles. So it's going to be the angle, angle, side. Angle, angle, side. So I can say yes by angle, angle, side. Okay? All right, let's look at the next one. When I look at the next one, I'm going to have this single tick mark, NP matches with PQ, NR matches with QR, and then remember I'm using the reflexive property to say this side in the middle matches. So again, that's using the reflexive property. Is what allows me to say that PR is congruent to itself. Okay? All right, so I can see I have all three sides highlighted. So when I look here, all three sides are highlighted. This is a yes by side angle side. A yes by side angle side. Okay? All right, when I look at the next one, I can see I have MP matches QS. I don't have any other tick marks, and I don't have any reflexive sides. Angle M matches angle Q. And then I don't have any vertical angles. Those kind of look like they're almost right angles. They almost also kind of look like they're obtuse angles. So I can't just make an assumption about them. So all I have is one angle and one side. That is not enough. So when it says, can they be proven congruent? No. Does that mean they're not congruent? No, that doesn't mean that either. I can't prove they are congruent. I can't prove they're not congruent. I can't prove really anything about them. Okay? All right, when I look at this next one, I have a single tick mark here that matches with that one. And then I have this shared side, so that is again my reflexive property of equality. Okay, so then, do I have any angles? Yes, I can see I barely see it. I kind of highlighted over it. I have an arc mark there and an arc mark next to it. So I do have two sides and an angle, so it's either SAS or ASS, and we don't like the second one. So when I look, if I'm doing right here, I've got my two sides, and then my angle is right here where my two sides come together. So my two sides and my angle is where the two sides come together. So that is a yes by side, angle, side. So yes. And we're using side, angle, side. Okay. All right, and now let's look at the last two here. Okay, so I have EM is the same as PQ, EN is the same as PR, and angle N has an arc mark on it, so it matches angle R. So again, I have two sides and an angle. Two sides and an angle. So I want to know, is it this one here? Is it my side, angle, side? So when I look, are my two sides coming together at the angle? No, my two sides are coming together up here at angle E. This one is not here. So this one is my side, side, angle, SSA, or angle, side, side, ASS, which is the booty. We never trust the booty, right? So this one is a no. We don't have enough information. Okay, not enough information on that one. All right, let's look at that last one there. For the last one, I have a reflexive side, but I don't have any other tick marks. So I just have this one reflexive side. Okay, and then I can see I have a single arc mark right here for that angle that matches the one over here. And then I can see I have this double arc mark that matches this one here. So I do have two angles and I have a side, so it's either going to be angle, side, angle, or angle, angle, side. I just have to decide which one it is. So when I look, which one is it? I got my segment, and then my circles are on both ends of my segment. So I have my segment, and my circles are on both ends of my segment. So that means this one is angle, side, angle. Angle, side, angle. So this is a yes by angle, side, angle. And I should have been, I've not been good at it, I should have been putting my little congruent symbol after it each time. Okay? Oops, that's kind of hard to see. There we go. Yes by angle, side, angle. Okay? Now, sometimes it's going to still ask you to keep doing a little more work. It's going to want the congruent statements. So remember, sometimes you might have to go back in and write your congruent statements, right? So we can say by angle, side, angle, congruence, triangle STV is congruent to triangle, and then just make sure you're consistent. If I started at S on this triangle, I'm going to start at U. And then from S, I went to T, which is my single arc mark on this triangle. So from U, I'm going to go to V, my single arc mark. I'm going to make sure I can tell the difference between my U and my V. And then end up at T. So make sure you can also write your congruence statements. Okay? All right, I am going to also do a couple videos looking at some proofs. If you're in a pre-AP class, you're definitely going to want to catch those videos. Okay? So make sure you are comfortable using these postulates in proofs as well.